One day when browsing eBay, I found a listing for a set of desktop machine tools, a mill and a lathe, alongside plenty of cutting tools, clamps, vices, and collets. Ever since then, I found myself playing around, trying to find out what these machines, and more importantly, myself, are capable of. A simple starter project I found was a Knurling tool holder. I went with aluminum as the material for its easy machinability and cheap cost, which allows me to mess up and not put a giant dent in my wallet. I start off the build by milling out the step feature on the holder. This is the part where the screws on the lathe tool holder will clamp down onto. During this step, and all the others, I'm playing with the speeds, feeds, and depth of cut on the machine, responding to what I'm feeling and hearing from the machine. I'm running this using a 3/8 inch 4-flute end mill, which allows me to mill out most of the material in a single pass. In this last pass, there was a slight radius on the edges of the step, so I need to clean both of these up. Next, I need to mill out both the chamfers. I don't have any chamfer mills, so I use this ultra-precise method to set the part at a 45-degree angle. Beginning of the cut, everything sounds nice, until I realize I forgot to lock the spindle in place. Luckily, I chose aluminum, and I wasn't terribly far in the process, so I started from scratch. Milling out the chamfers this time, I double-checked to make sure that the spindle lock was on. Luckily, I double-checked it. Before milling out the center, I use an edge finder to find the exact center. Milling out the center slot first, I'm very careful with the depth of cut, only taking about 10 to 15 thousandths per pass. As I continue, I eventually get a little bit more aggressive and go up to about 45 thousandths by the end. With everything done, the last thing to do is tap one side of the holder for the retaining screw. For the assembly, I found myself a nice retaining screw with a round section on McMaster Carr, alongside a straight Knurling wheel. Overall, I think the build came out quite nicely. Looking back at the footage, I realized I could have been a lot more aggressive with my depths. Everything took longer than I'd like to machine, but I found that 1700 RPM works quite nicely for just about anything I've done with aluminum ever since this build. Thank you all for watching. This is the first video I've ever done on YouTube, and I've been sitting on this for the better part of a year now. I'm glad I finally posted it. And if you have any project ideas, suggestions, or tips, feel free to comment below. Other than that, have a blessed day, and I hope to see you all in the next one.